Our new video lecture on the research process series in quantitative methods, and we've already finished the conceptual phase and also discussed about chapter 1, which basically articulates the conceptual phase of the study that you will do or you are doing. Now we're going to be talking about the design and planning phase, or the methodology of the research. So there are going to be two parts. The first video lecture will be on research design, sampling, and research methods in terms of data collection. And then for part 2, we'll talk about instrumentation, data gathering procedure, data analysis, and rigors in quantitative research. So basically, for this lecture, we'll be talking about the different quantitative research designs, which we briefly discussed earlier in the research process, but we'll be discussing in more detail in this lecture. And then we'll talk about the different methods and data collection procedures that is used for quantitative social research. We're also going to talk about population and sampling. It is about the who of our study. And we'll also talk about different sampling techniques. So let's talk about the research design. So the research design is the overall blueprint that guides the researcher in the data collection strategies. It also guides us in relation to what type of data we will collect, what are the samples that we are going to make use of, and also when we are going to collect the data, and how do we treat the independent, the dependent variables, and the other variables in the study. So basically, when we talk about quantitative designs, there are two general types, and these are experimental design and non-experimental designs. And under non-experimental designs, we have cross-sectional and longitudinal designs. Now, what is the difference between experimental and non-experimental designs? Experimental designs basically make use of an intervention at its independent variable. So the researcher basically introduces an intervention or a treatment in the study in order to see how it affects a specific population. And for non-experimental research or non-interventional research or observational research, basically what it does is just measure the variables in their natural state and not really introduce some form of independent variable or treatment in the study. And if you remember our first lecture in the research process video series, we also talked about other forms of research methodologies or research typologies. And we talked about exploratory, wherein there's really not much known about the given subject, and our goal is to be able to see what is happening in a given phenomenon. Usually we use qualitative research for this. And then we have descriptive research, that is usually both qualitative or quantitative methods. And basically the goal of descriptive research is to be able to describe the magnitude or the extent of a given phenomenon or a variable in a given population, and probably look into simpler relationships. And then we have explanatory research, which goal is to be able to look at more complicated or complex relationship between and among variables using quantitative methods. And then we also have predictive studies that uses even more complex statistical methods in order to see more complex relationship between and among variables. Usually we can use experimental studies here, or we can also make use of longitudinal studies here, where you follow a specific population and how a certain variable develops in a given amount of time, from time 1 up to time 2, 3, and so on and so forth. So now let's talk about experimental research. So again, another name of experimental research is interventional research. So by context clues, you know that in an experimental research, the researcher introduces an intervention or a treatment in the study and tries to see whether or not that intervention or treatment has an effect on the population through the measurement of the change in a variable from time A to time B. Now, there are three components or elements that says that a certain research design is experimental. The first one is manipulation. So, what does manipulation mean? a researcher exposes the participants to an intervention or treatment, or the independent variable in the study is an intervention or a treatment. Like for example, if you want to improve the confidence of the athletes, the independent variable can be something that you expose them to, or you give them. For example, you provide them a seminar, or you provide them team building activities, and you're going to see whether or not the team building activity will improve their confidence over time. The second element is that there should be experimental and control group. So, in short, in an experimental study, ideally, there should be two groups that we are testing. We have the experimental group and the control group. So, the experimental group receives the experimental or the intervention condition in the study, and the control group does not receive the intervention in the study. So, for example, in our case earlier, where the treatment is a seminar or a team building activity in order to increase the confidence of the athletes, what we can do is we divide the total group into two separate groups. The first group is the experimental group, and the second group is the control group. And the experimental group will receive the team building activity, and the control group will not receive the team building activity. And then what the researcher will do is that the researcher will measure the confidence of the athletes for both groups before and after the time of the experimental condition, and then the researcher will compare the results of the change in confidence for those who were exposed to the team building activity and those who were not exposed to the team building activity, with the hopes, of course, that those who were exposed to the team building activity would have higher increase in level of confidence compared to those who were not exposed to a team building activity. And then the third element of an experiment is the random assignment. Means that the assignment of subjects to the experimental or control group should have been randomized. So for example, you have a group of 60 athletes that you want to include in the study, and then you're going to divide the athletes to two groups of 30, so 30 for group experimental and 30 for group control. The selection of the athletes should be randomized so that we are sure that the distribution of the athletes is normal for both of the groups, so that they are really comparable. I'll give another example. Let's do a medical example this time. So, how do we know if certain vaccines, are really effective in decreasing the risk for getting COVID-19? So this is the more simple way of explaining this. So the independent variable in this study is exposure to a vaccine, and the dependent variable is the risk of getting COVID-19. Right? So the goal again for experimental research is that the independent variable is provided by or is manipulated by the researcher, meaning it is the researcher that is exposing the group to the vaccine or no vaccine. All right? And then the second one is that there should be an experimental group and a control group in the study. So again, the experimental group is the group that will receive the intervention of interest. So in this case, the experimental group will receive the vaccine. And the control group is the group that will not receive the intervention of interest, and this will be those that will not receive the vaccine. All right? So, how do we now do this? So first is, in a given period of time, let's say pre-vaccination period, they measure the risk of getting COVID-19. Usually, that is given as O. That is the notation. So O1, and that's going to be the same for control group. So they're going to be measuring COVID-19 risk for both the experimental and the control group. And then you have the intervention phase. So for the intervention phase, who will receive the vaccination? It will be the experimental group. So that will be represented by X. And for the control group, they will not be exposed to the vaccine. Instead, they will be exposed to what we call a placebo. When we say placebo, in medical terms, it means that the content of the syringe or the medication is just water, no, or saline water. And then we have post-test, no, and the researcher will measure again the risk for COVID-19 sometime after the intervention has been provided. And then what the researcher will do is that they will compare. Now, for those who were exposed to vaccination, did they have more risk than those who had control, or vice versa? Of course, what we know based on the studies that we have for the vaccines that we have for that are being administered in the globe right now is that the experimental group in the trials that were made for COVID-19 vaccines, that those who were exposed to COVID-19 vaccination had lesser risk of getting COVID-19 compared to control group, no? And this is not really just risk to COVID-19, but really risk of getting hospitalized for COVID-19. Now, the third component or element of an experimental research is random assignment. So when we say random assignment, no? So for random assignment, what we mean here is that the distribution for those who will go to the experimental group and control group will be randomized. So if you have a pool of 1,000 volunteers, 500 will be going to the experimental group, 500 will be going to the control group. How do you identify the 500? Should be randomized. Usually, how do we do randomization? Using electronic randomization. So there are applications that can be used to automatically randomize people. Now, of course, there are ethics here, no? What also increases the research, no, these types of research is what we call double blinding. So when we say double blind, no, this is when the researcher and the patient do not know that whether or not they're taking a placebo or a vaccination, so that they will not have a psychological reaction to what is provided to them. So they don't know if they're receiving saline water or if they're receiving the vaccine. Of course, there's ethical protection for that. The risks are weighed. And at the end of the day, at the end of the vaccination trial, those who go to the control will be receiving free vaccines, especially when the vaccines are known to be safe. So that is also their benefit as part of the being part of volunteering to be the part of the study. Now, if double blind is achieved in the experiment, this experiment is called a randomized because there was a randomization, clinical trial because there is a double blinding, no? So that is a more specific type of experiment. So can you do that in sports studies? For physical, no, for example, you want to see whether or not certain nutritional supplements will be able to increase, let's say, it will be able to increase muscular power, no, or endurance, no, or if vitamin supplements will be able to increase the endurance of the athletes, you can do that, no? Provide experimental group with the actual natural supplements, and then the other one will just be receiving a placebo, no? Yun yung placebo. So that's, but for social research, a double blind is almost impossible, no? Because if it's a social intervention, like for example, seminars, for example, team building activities, or trying out a new coaching strategy, or trying out a new type of pep talk, it's impossible to do a placebo because it's hard to be double blind, no, especially when you're the one doing the placebo, no, or the control condition. So yun siya. So this is another example of an experimental study. Now, most of the studies that you are doing, no, that you have done for your previous assignments, they're really not experimental, no, because it's difficult to do an experimental study because you have to really be there, no, to be able to implement. Because remember, in an experimental study, you are the one who is controlling the independent variable. right? So if you are not with your participants, especially during the quarantine, it would be quite difficult to manipulate the independent variable. But experimental designs are better than non-experimental designs in trying to establish causality. No? So when we try to in quantitative research, we measure relationships between variables. Now, when we say relationships, there are different types of relationships. There are relationships, the most common one are just correlations or covariances. Na ibig sabihin, when one goes this direction, the other goes this direction, and seemingly there's a pattern to it. But you cannot really say that it is that variable A causes variable B, no? Or variable A influences, affects, or impacts variable B, no? Especially when you do it in a non-experimental way, no? There's also a predictive relationship, and usually predictive relationships, usually there is a higher level of stats that are being used here, like for example, regressions, no? So that's a predictive relationship. Now, causal relationships, it could also be done by higher statistics in a non-experimental research, but usually for causality, that is influenced by, or that can be determined by experimental studies more than non-experimental studies. So what are the requisites, no, of causality in experimental designs? One, there should be covariation. So how do we know that A is a cause for B? No, so one, there should be covariation. As the independent variable changes, the variable also should change. So if there's no change, or their change doesn't seem to really establish a pattern, then there's no covariation. Number two, time order. Independent variable should happen prior to the dependent variable. It means that the independent variable should almost always exclusively happens before the dependent variable exists. Now, where's the issue here? Now, for example, we know that when you get a vaccine, no, you will decrease your risk for COVID-19. No, so you cannot have decreased risk for COVID-19 prior to the vaccine. No? Another thing is, for example, the nutritional supplement, no, should have been the cause, or should have happened before getting extra muscular power, no, and it should not be the other way around. Or so when are the times that we may not be sure about the time order in non-experimental research? Like for example, no, there is that prevailing notion that academic performance is an outcome of stress, right? So stress can influence academic performance. But also, academic performance, especially when it's poor, can also affect academic stress. So the time order here is not very much established, especially in a specific basic statistics that you use. You can only say probably they are correlated, but they're not necessarily causes, no? So remember that term. Correlation or association doesn't necessarily mean correlation doesn't necessarily mean causation. So that's the main, no? So again, I will write here, no? So correlation doesn't necessarily mean causation, no? Kaya, for example, when somebody drinks ivermectin, no, I know I probably have heard of this issue before. When somebody drinks ivermectin when they get COVID-19 and they eventually recover from COVID-19, yes, there's a correlation between taking ivermectin and losing the COVID-19 symptoms. Pero it doesn't necessarily mean that it's a causation, no? Unless you have another group of people who do not take ivermectin, and those who do not take ivermectin had worsened their COVID-19 symptoms, and probably we could say that ivermectin had been a cause, no? But for example, we find out that the experimental group, those who received ivermectin, had a decrease in COVID-19 symptoms as they drank ivermectin, and those who were not drinking anything, any medication, they just rested, they also got recovered from the COVID-19 the same time that the ivermectin group also recovered. So that means that it just so happens that you were taking ivermectin, but whether or not you were taking ivermectin or you were not taking it, you will eventually recover. So the recovery doesn't have something to do with ivermectin. There was just a pattern. So I think this is something that you will always have to remember. When somebody comes to you and says, you know what, you have to try this nutritional supplement, you have to try this new whey protein, you have to try this fat loss product because it worked on me. It worked on me, based on my experience after I drank this and, added a little bit of more of diet. I had lost my weight, and I had more muscular mass, and that's something I do. But that is just one story. That is just a case. Or for example, I had a group of 10 people, we all took this whey protein, we all took this fat reduction product, and we all gained good, higher muscle mass, less body fat after a few days. So this must have worked for us. And that is just a cohort, just one group of people, but there was no comparison group, but a full experimental research would also have a separate group who will not be receiving that treatment, and if that group not receiving the treatment does not have the results that those who are receiving the treatment has, then it means that the treatment is working. That might mean that the treatment is working. But of course, there are more to that. Sampling, variables being taken, control of extraneous variables. But that is one way that we can say that it is. So be very careful when you're trying to listen to news about whether a certain, for example, this certain supplement, I take this and I didn't get COVID even if I'm not. So probably this supplement is good. Question yourself, was there an experimental study, a randomized clinical trial that used this and really said that this is effective? Because if it's not, then probably you don't easily believe them. And finally, nonspuriousness is another requirement. The cause should have been the IV and not the extraneous variable. So, what does this mean? For example, you had you wanted to see whether or not doing a video lecture will increase the knowledge of students in relation to sports versus traditional. Traditional is your control group. Video lecture is your experimental group. And probably you were able to find that yes, those who were in the experimental group had higher knowledge compared to those who were in the control group. But wait, did you really make sure that those who were in the video lecture group were not able to search in Google? Right? Or were you able to control for this group in terms of their sports exposure? How do you know that the increase of knowledge really happened because of the video lecture and not because they were watching sports and watching other videos aside from yours? How can you be sure that it was the video lecture? And there are many controls that we can do in order to control extraneous variables, and probably there could be statistical tools that you can use to control extraneous variables. You can do complex stats, or you can control the population in terms of selection. Like for example, the distribution of the population should be the same for males and females so that the effect of gender will not have an issue, etc., etc. So, nonspuriousness. Now, this is one of the more difficult to achieve in a study. That's why some experimental studies are really difficult to study. That's why that is not what I am proposing that you do in your thesis or your dissertation. You can try, but this is really very difficult, because you have to meet all of the requisites, the requisites from these three, manipulation, experimental, and random assignment, and also when you already now are going to interpret your findings, was there covariation? Are we really certain that A happened before B? And number 3, are we sure that the effect is really from the experimental condition and not because there was other extraneous variables that could have affected it? So now let's move to non-experimental design. So what is the difference of non-experimental designs to experimental designs? Non-experimental designs do not have interventions or treatments or experiments being done, meaning the independent variable and the dependent variable and all other variables that are used in the study are measured in their natural state, either through survey or observation or other forms of data collection. So we do not introduce any form of intervention. The first type of non-experimental study is cross-sectional design. So this is the most common method in social science in general. So in general, in social sciences and social research methods, this is the one that is mostly used because I would say this is the easiest to do in relation to non-experimental research. And this is also true in sports studies. And basically, you take it from the context clues. You take a cross-sectional sample from an overall population. So that's one of the criteria. And then we collect data through surveys, through questionnaires or interviews. And then when an independent variable cannot be manipulated by the researcher, this is usually where we use cross-sectional study. Like for example, if we see that gender is, for example, related to, let's say, sports performance, we cannot manipulate gender because, we cannot say na, you're male or you're female. We cannot assign gender to people, just like in an experimental study wherein we can assign a certain person to be exposed to an intervention or not. Gender, we cannot assign people to gender because they have inherent genders already. They have inherent household incomes. They have inherent self-esteem, So if the independent variable cannot be manipulated by the researcher, usually that is when we go for a non-experimental design to a cross-sectional design. However, as I explained earlier, this designs is not as good as experiments in terms of determining causality. Siguro the best that we can establish in cross-sectional design is correlation, and also prediction, but not really causation. It is quite difficult to establish causality in a cross-sectional design. So now most of your studies that you are doing, that you are proposing for this subject, usually they fall under this. They are descriptive cross-sectional designs that are correlational in nature. It's correlation. Now, another form of a non-experimental research is longitudinal design. So what is the difference of longitudinal designs from cross-sectional designs? A cross-sectional design, you collect data in one period of time. Like for example, you collect only in the month of May or in the month or in a specific given of time, and do not compare it across years, across time. But if your goal is to be able to collect the variable or collect data of the same variable through multiple periods in time, using the same sample group and measures particular variables over an extended period of time, then that's a longitudinal design. So how do we name a certain design? So when we name a certain design, first we identify what approach. So the approaches are either quantitative, qualitative, or mixed methods. Again, the mixed method is both quanti and qualitative designs. And then after that, you look into the typology based on the purpose. So based on the purpose, you have exploratory, right? So if you remember, exploratory, descriptive, and then predictive, and also predictive and explanatory. And then after that, you identify which specific design. No? So this one, approach, purpose, and then the design. You have the experimental. And then you have cross-sectional. And then you have longitudinal, either retrospective, or you have prospective. Okay? And then, lastly, what type of relationship are you looking at? So, if you're just doing association or correlation, the study is correlational. Right? And then, after that, you also have predictive. So, what is the difference here? The type of statistics that you are using, and also the type of measurement for the variables. And also, for that is for the non-experimental. For experimental, we know it's causal. So, for in most of your studies, the design is usually quantitative, because you are measuring it going to measure it via numbers. Now, why do we measure it? Because you said what is the level of, no? You're going to count how many in terms of gender, how many in terms of age, no? And you're also going to also measure them quantitatively, the different variables in your study. And then it is descriptive, no? Because you are not really exploring, because that's usually qualitative. So it's descriptive. And then it's cross-sectional, because you're usually collecting the data one period of time. And it's also correlational, because you are correlating the antecedent variables with the main variable, and the main variable with the outcome variables. So the whole research design is a quantitative research. It's descriptive, correlational, and it's also a cross-sectional research. And then I will just like to give you a review of qualitative designs. I know that this will be discussed to you in your quali subject, no? But just to give a review, no, we have case studies wherein we do a qualitative exploration of a given case, whether it's a person, a team, an event, an organization, or an activity. And then phenomenology, when we want to study about the lived experiences, no, of the individuals in question. And then for grounded theory, it is when we want to create a theory or framework based on qualitative data. And for ethnography, this is when we do participative observation participant observation in order to describe very immensely a culture or a cultural practice. Now let's go to population and sampling, but first let's define some important terms. The first one is population. Population talks about the aggregate of the total number of people that fit the criteria for the study, or basically who are the target people who you're going to collect the data from in your study. So when you say that you're going to collect data from student athletes in the university, then the total number of student athletes in that university that fit that criteria is your population. And the actual number of that target population is called your sample size, no? And that is represented by the big letter N. And then we have the sample, and the sample is the set of people from the population, or the segment of the people in the population you will be collecting data from to represent the whole of the population. Sometimes there will be moments wherein there's too many people in your population that you cannot collect data from everyone, and you only need a certain number of people in order to represent that population, and that is called your sample. As seen in this diagram in the right, you'll see that if this is your target population, and for example it's too many and you cannot collect data from all of them, you can collect a sample from this population, and you'll collect your data among the sample. And if you are doing that process correctly, then you'll be able to get and you're able to get and analyze data that can represent the whole of the population. For example, you might remember surveys coming from Pulse Asia or other large statistical or survey organizations. And they don't actually interview or get data from the whole of the Philippines to represent the whole pulse of the Philippines, but they just select a few number of people very strategically. They just select a small number of samples, and whatever data they get from the samples, they apply statistics so that it can represent the rest of the population. So really, this is more also related to making it more economical and more feasible to be able to collect data to be able to represent the rest of the population. And the number of people that we get for the sample from the population is called the sample size, and it's represented by the small letter n. Now, the process wherein you're selecting people from the population to the sample, that is called your sampling technique. Now, there are many sampling techniques that can be used, and we'll discuss that earlier. There are sampling techniques that are more reliable and more valid than the others, and we'll talk about all these types of sampling, which will be able to help you in terms of planning who you're going to select for your study. Another term is called the sampling frame. It's basically, this is the tool or the list where you find all of the name or the names of the people in the population who are eligible in your study. So for example, if your target population is the students enrolled in a given university, then your sampling frame is the list of the students that is found in the official registrar's list for that who are enrolled in that specific school, and that is your sampling frame. And your sampling frame is very useful because it will give you an access to the information in relation to your target population, and it will also help you in terms of your sampling and recruitment. Next will be inclusion criteria. So what is the meaning of inclusion criteria? Inclusion criteria is the characteristics that, when possessed by a certain person, makes that person eligible to be a part of your study. So for example, you're doing a study among student athletes and you want to set up an exclusion criteria. So you list down the different characteristics that make them eligible to be a part of your study. So probably your first inclusion criteria, there should be student athletes, So yeah, and then probably another for inclusion criteria is that they have to be 18 years old and above. Why? Because probably you don't want to include minors in your study because of ethical considerations. You also want them to be single, because you want to homogenize your sample and make them more alike, because you know that when you include other forms of civil status, it may also influence the effect of your influence the way the variables will come up in your study. Probably you can also choose like a specific year. Student athletes probably have played from this year to that year. You may want to also have that type of but again, this is the reason for all of the criteria must be justified in your study. So this is your inclusion criteria, and everyone who fits this, probably also in the selected university. So this is not all of the student athletes all over the world. This is student athletes that are found in a specific university. So all of the people who fit this criteria are a part of the population in your study. Next, we have exclusion criteria. So exclusion criteria is the characteristic when present in a certain person makes him or her disqualified to be a part of the study. So for example, probably there's a student athlete that who is 18 years old and above, single, who played within these years and was enrolled in a certain university, but this person for example, you set up your inclusion criteria, and in your inclusion criteria you included that there should be no injury. Currently, that the certain athlete should not be experiencing any form of injury or disability during the time of data collection. So maybe the person passes all these criteria, but because the person has an injury, then he will be disqualified to be a part of the study because, again, of some reason that makes that person not fit to be a part of the study. So when you try to plan the population and sampling for your study, you have to set up very specific inclusion and exclusion criteria because you want to be able to homogenize and make sure that you are collecting data from the correct people. And then other terms would be response rate. So when you say response rate, this is the amount of people who actually turned in the survey form completely out of the number of people that you've provided the survey. So for example, your sample is 400 and you gave out 400 surveys to 400 people, one survey to every person, every person of that 400 sample, and then you were able to only get let's say 360 completed, and then the 40 did not return their survey form. So the 360 is your response rate. And your 40 is your attrition rate. Of course, ideally, in your study, there should be more. A higher response rate is better and a lower attrition rate is also better. Now, how do we refer our people in the study? So if it is an experimental study, then we call them subjects, for experimental studies. Now, if your study is a survey study, like you're going to give out questionnaires, then that is called a respondent. If your study is using if your study makes use of an interview or you have to interview the people in the study, then they're called informants. Now, if the study is through a focus group discussion, then you can either use a participant or a discussant. So these are the terms that can be used in your study. Now, there are two types of sampling techniques. You probably have learned this before in your previous statistics classes. The first one is probability sampling technique. And under probability sampling technique, basically, these are all sampling techniques that leave an equal amount of chance for everyone in the population to be selected in the sample. So the first type of probability sampling is simple random sampling or fishbowl or lottery method. For example, your total population is 1,000 and the sample that you need for your study is just 100. So how do you select the 100 from the 1,000? So you have, for instance, your sampling frame, and from here you select 100 people. How do you select? It should be very random. So it's either, of course, you do this by lottery, by draw lots physically, or you can actually ask an application in the internet to do the randomization for you. And again, the good thing about there is that everybody has an equal chance to be a part of the study. Next, we have stratified random sampling, cluster sampling, and systematic sampling. So for stratified random sampling, you will first divide the population into reasonable or justifiable groups, justifiable groups. Like for example, you want a proportionate number of females and males in the study. So for example, you want 50% of the 100 to be males and 50% of the total sample to be female. So you divide the group first. You divide the sampling frame, males and females, and for each you collect 50 to make sure that they are equally represented in the study. So in simple random sampling, you take them all. regardless of the groupings. But for stratified sampling, you stratify the group first based on justifiable groups or important groupings that you need to be proportionate by in the study, and you are going to do random sampling for each of the groups. So that is the difference between simple random sampling and stratified random sampling. When you say stratified, it came from the word stratum, and stratum means group. So what you do again, so from the population, you group based on justifiable groups like gender, for instance, or for example year level, and then from the group you do randomization. So next is the systematic sampling. So for systematic sampling, you are going to get the kth of the population. So what is the kth? Kth is n, big N over small n. So for example, you have 1,000 for the whole population, and you only need a sample of 100, so 1,000 over 100 is 10. So for example, you are owner of a sports bar, and you want to know the level of satisfaction of customers in your sports bar, and in a week, you are assuming that you are getting 1,000 customers in that sports bar. So what will happen is that in order for you to get 100, you're going to get data or administer your survey to the 10th person in the to every 10th person who enters the sports bar. So just like here, the selection is per 3. So 1, 2, 3 select, 1, 2, 3 select, 1, 2, 3 select. So in your case, in our hypothetical example, we are going to collect every 10th person who enters the sports bar. So something to that extent. So these are the differences in all the probability sampling. So again, what is the common among the probability sampling methods is that there is a large amount of chance, equal chance, that is afforded for every part or every person in the population to be selected in the study. So there's equal chance. Next, we have the non-probability sampling technique. So for non-probability sampling techniques, there is a decreasing likelihood that there is an equal chance to be selected in the study. So there is already some form of bias in the collection of the study. And therefore, because there is some sort of bias, the generalizability of the findings may be dampened compared if you would do it in a probability sampling technique. But usually we do this because there is some logistical or feasibility issue to do probability sampling. Like for example, in random sampling, you need a sampling frame for you to put in a randomizer in order for you to get the list of the randomized sample. But when you don't have the list, for example, you don't have the list of the students, then you don't have anything to randomize. So those are some logistical issues in terms of doing probability sampling. And sometimes, some researchers would do non-probability sampling. And what are the common examples of non-probability sampling? We have convenience sampling, quota sampling, purposive sampling, and snowball sampling. Before I forget, snowball sampling. And we have theoretical sampling that is used in grounded theory. And then we also have what we call universal sampling or total enumeration. So before I explain the first 5, let's go first with total enumeration. Total enumeration is when you collect all the data from all of the population. You don't get a sample. For example, there's only 100 people who are eligible to be a part of your study for your big N, and you collect all of them, and you don't get a sample anymore, then that's called universal sampling or total enumeration. So this is a better form of non-probability sampling, especially when you have a small population in the first place. There's no logistical issue of taking all of the population in the first place. So let's start with convenience sampling. So convenience sampling is, for example, you need, the total population. The total population is 1,000, and the sample that you need is 100. Now, the question is, how do you get the 100 using convenience sampling? So the first, if this is the researcher, the one in gray is the researcher, all the first 100 that is nearer to the researcher, the first 100 people that the researcher sees or collects data from is the sample. So it's convenience because it's nearer to the population. So that is your convenience sampling. So there's a bit of bias there because not everyone has a chance to be selected in the study. There is some form of randomization there because, of course, the researcher does not choose freely who to get. It's really based on whoever is available at the moment. But this is a little bit biased because how about those people who are not available but are also eligible to be a part of the study? So that is for convenience sampling. Most of the studies that we do in the undergrad will allow convenience sampling because again, this is more logistically feasible. Next, we have quota sampling. No? So quota sampling is just like stratified random sampling. So when you say stratified, if you remember stratified random sampling, you have the population, right? So if you remember, you have your population, and then you divide them into groups. Like for example, you are going to divide them into useful groups like first year, second year, third year, and fourth year. And then you're going to select proportionately for each. But for this time, it's not anymore randomly selecting for 1, 2, 3, and 4, but you're going to select it using convenience sampling. So this is like, quota sampling is just like a stratified version of convenience sampling. Quota because you're going to set a proportion for each of the group 1, 2, 3, 4. You set a quota for each, and then the first available people for the first year that will come, for the second year that will come, for the third year that will come, and for the fourth year that will come will be the ones that will be included in your study as soon as you get your quota. Next, you have your judgment sampling, or we more likely call them purposive sampling. So purposive sampling is when the criteria of your sample is so specific, it's not easily to just choose them via random or convenience sampling. For example, you're looking for athletes who have undergone ACL injury. It's not every day that you find someone with ACL injury. You have to seek out and look for them. As seen in this diagram, it is the researcher who is trying to find them. Why? Because they're not easily found in public. They're usually you have to really invite them. You really have to cast out invitations so that you'll be able to find them or make ask for referrals, and you have to seek them out, go to a certain to people and ask about the existence of these persons because again their criteria is so not like for example student athletes. Probably you can just go to the university, to the department and say, I would like to collect data from student athletes, and they're easily accessible. But it's not as accessible when I want to look for student athletes with injuries, and you really have to ask around and seek these people. That's why it's purposive. It's the researcher who is it is based on the researcher's judgment and own volition that they are being selected to be a part of the study because of specific characteristics. And next we have snowball sampling. Snowball sampling is can also be considered as a snowball, as a purposive sample, but instead of the researcher just seeking out, the samples in the study, the participants in the study, the participants also refer to the researcher the next participants. An example of a snowball sampling is, for example, you're doing research on people who are suffering from drug addiction. And of course, again, these people are not readily available in public. So probably a few people who are experiencing drug addiction and you interview them, and then at the end of the interview you ask them, do you know anyone else who has drug addiction, and they may refer you to someone. So the ones who keeps the ball rolling in terms of sampling and recruitment of participants is the is the sample, no, and then the next sample will recruit or will invite or refer to you a new sample. So that's why it's snowball, no, when the snowball rolls at the side of the hill, it gets bigger and bigger and bigger. So it is as you go along and do your data collection, your sample size gets bigger. And then going back here, you have also your theoretical sampling, which is specific to grounded theory research, which is qualitative. Let me just give a short explanation for this, no? So theoretical sampling is that you get data where the theory that you are developing leads to. So that's basically what it means. Now, the next question is, so we are just hypothetically saying, n is equals to 1,000 and probably the n is equals to 100. Now, what is the basis for the small n, Again, there are many ways to identify how many people from the population you will collect. And most of this can come from computation, some of these come from limitation, etc. So what are the ways for you to identify sample size? One, you can do the total population. So universal sampling. If you can, you don't have to do sampling technique anymore. Just get the whole sample. But again, this is not always logistically feasible because especially when you have 1,000 students. So are you going to collect data from all the 1,000 students? So that's also something that you think about. No, what if you need a smaller sample compared to your population, but you need to get a number for the small n based on scientific and valid methods? You can use sampling formulas, and there are 3 that are available. We have Slovin's formula, we have Cochrane's formula in G-power analysis, and you may have come across of this in your statistics classes, no? And then we'll review that later. Or for qualitative research, we use data or theoretical saturation. Basically, you stop collecting data when your qualitative data is already redundant and you've already established thematic patterns from the initial analysis of your study. And then you have your previous studies. So some previous studies can give you an information on, for example, you're doing an experimental study, how many did they get for their experiments, and if you feel that's acceptable, you can also use that number for your own study based on what the RRL is saying. So you can use this formula. No, this is Slovin's formula. The sample size is equals to population size all over 1 plus population size times the margin of error. So usually the margin of error, we have it either for 0.05, that's the most common, no? But others, they have it as low as 0.01 and some as low as 0.1. So this is the acceptable for behavioral sciences, 0.05. So this is an example of a computation. If you have 240 in the population, based on the Slovin's formula, you need 173 for a 0.04 margin of error. But again, the computation should have been 0.05. So the lower margin of error, the higher the size that you are going to, that the computation will be providing you. So this specific study will need 173 or 174 students. So it's good to also compute for the Slovin's formula. And then that's the time you decide. So how do I get the 173 from the 240? Do I use random sampling? Do I use convenient sampling? Do I use quota sampling or stratified sampling? It's up to you based on your needs and based on the type of validity that you want to achieve for your study. Next, this is the Cochrane's formula, no? And you can use this formula also, but this one is usually for research that uses proportions instead of means. But in the social sciences, we usually use means rather than proportions. And we can also make use of G-power analysis or other calculators. The basis here is not really the population size, especially if you're not sure about how many the population is. So for example, you want to just get it from general adolescents in an urban population. You don't necessarily know how many adolescents there are in the urban population, so you will not be able to do a Slovin's formula. So this is good when the big N is not known, no? So what you can do is you can use a sampling calculator using G-power analysis, and then key in your a number of antecedents or number of factors, and that will give you what they will tell you. Oh, for example, I have 5 antecedents or 5 factors in my study, and these are the level of power, and 0.8 is the normal number, is the good number for power, 0.15 is the good number for effect size, and the probability level is 0.05 is also the one's ideal for social science research. And for determining the relationship of a dependent variable with 5 independent variables, we can have 91. No? And this is an example, danielsoper.com. You can find it here. No? Next, after getting your design and then identifying who your population is, identifying the sample size, and identifying the correct sampling technique and recruitment process that you need in order for you to get your population, it's also important for you to identify data collection procedure. No? Again, you can either use secondary data or primary data. Again, secondary data is the data that is already available, and all you have to do is just make analysis. Now, again, this is not usually what we do in our thesis because we want you to actually collect primary data. Okay? So, a primary data is when the researcher will collect new data for the specific study that they are doing. Now, what are the common data collection procedures in social science research? The most used are surveys or questionnaires, and this is what we will be discussing in the next in the next video lecture, no? How to create questionnaires. Now, remember that for questionnaires, for each variable, no, each variable has to be measured by the questionnaire. No? So if you have social demographic characteristics should be asked there. No? If you have physical activity or level of physical activity, there should be questions about that. And we'll discuss about questionnaires. And then you can also do interviews. So for interviews, this is where you sit down with your participants and then you do a meaningful conversation, and through this meaningful conversation, you are able to collect new data. Now, what is the advantage of interviews? Of course, the advantage of interviews is good for qualitative research because you get a bigger depth of data from a single person compared to a quantitative data. But the cons of this is that it takes more time and it takes more effort. No, probably now it's easier because you do it digitally through Zoom or Google conferences. But it still takes time. No, and the advantage of using questionnaires is, one, it's already structured based on the variables in the study, so it's perfect for quantitative research because you are already structuring the measurements based on the variables you are measuring in your study. And number two, it's also quicker. No, you get to administer it to more people in a shorter amount of time compared to interviews. And then, of course, we have what we call direct observation, wherein instead of the participant or the respondent providing us the numbers or providing us the data collection, we observe it. So, where is direct observation good, at least in support studies? Like, for example, they have to perform an endurance test. No, for example, of an endurance test is you're going to ask them to run around the oval and see how long they could go. So that's not something in a questionnaire form. You just say, how long can you last in terms of running? And then they say, I can last 1 hour of diretsong running. But the problem is that it's not verifiable, because it's just based on their self-report. But for direct observation, you are going to ask them to run around the oval and see how many laps they make in a given amount of time, and that is their score for endurance. So instead of them reporting to you the value, you are measuring the value as they do it. So this is good for physiological measures, like, for example, heart rate, speed, flexibility, because you can do this. But of course, that is good for sports sciences rather than sports studies, because sports studies is more leaning towards the social sciences, which will require interviews if it's quantitative. Interview if it's qualitative, and questionnaire if it's quantitative. And then we also have participant observation, wherein the researcher immerses themselves into the specific cultural group or a specific institution in order to have an in-depth knowledge of that group or institution or organization. And this is usually done in ethnography, no? And you will learn this in your qualitative. Now, and then you can also do document content analysis. Like, for example, you just want to study whether or not the career of certain basketball players already playing professionally. You can probably you can already have this, no, using your you can already see this from the data collected by, let's say, the PBA, no, the history of assists, rebounds, etc., etc., no. So that's a document or records review, no. Another would be, for example, of content analysis or document content analysis is, for example, you want to know how many what are the themes, no, of that are being tweeted by sports athletes during the time of COVID-19, no. So this one is not really a document that's paper, but really this is more of a social media documentation or social media text that can also be content analyzed. So social media, just like Facebook, Twitter, can also be analyzed using quantitative. So that is it for our designs, method, and sampling discussion. Remember that this is really more of an overview, and you will be learning more of this when you do your actual thesis paper, no? And I will also be including other resource materials in the module for you to have deeper knowledge on all of these methods, on all of these sampling techniques, and all of these designs, so that you can have additional knowledge. So these are just overviews based on our reference material. So I encourage you to read more research and to read more textbooks and to watch more videos in terms of research methodology. And then in the next video, we'll talk about how to construct instruments, no, which we know as questionnaires. How do we also make sure that validity and reliability is high in our studies, which is very much important when you do quantitative research.